So this is lesson number 3, and we'll talk about the blockchain design principles, and we'll discuss 3 generations of blockchains. So in the previous lessons, we did a quick overview of how Ton works, and this gives an impression that it's quite a complicated system. So to give you a little bit of a perspective, let's go back a little bit and talk about how Bitcoin and Ethereum were designed and what are the key differences from Ton. So let's start with Bitcoin. Bitcoin was designed almost 14 years ago. This was the first cryptocurrency and the first blockchain that was ever created. And this really solves a very narrow problem and does it very well. And the problem it solves is the censorship-resistant digital cash. What do I mean by this? So Bitcoin is only concerned with giving you an ability to transfer units of a virtual currency called Bitcoin from one person to another. And the way it does it is by using very few tools. So every transaction in Bitcoin is a transaction that transfers the coins from one public key to another public key. Okay, so let's start with the simplest ledger that is implemented in Bitcoin. The idea of Bitcoin is that you have a ledger where each account is identified by a public key. So every person has a secret key in their wallet application and the public key visible on the ledger. And every time they want to transfer the money from their account to another, they make a transaction where they cryptographically sign this transaction with their secret key and announce to the entire network that they're transferring money from their account to someone else's. In Bitcoin, it's a little bit more complicated than that because Bitcoin tracks individual accounts with their balances and effectively destroys them when they're spent. So if you want to spend a portion of the account, then you have to make a transaction that has 2 outputs. One output will transfer some portion of money, say 10 coins out of 100, to your destination recipient, and the rest, 90 coins, will be sent back to your own address, and this will effectively create a new account. So in Bitcoin, this ledger looks like this sequence of multi-input, multi-output transactions that create and destroy those accounts as you go. And the entire state of the blockchain is simply the list of currently unspent accounts, where each account is a public key and the balance. So the state is pretty simple, and there's not much room for flexibility. Except, in the late stages of development in Bitcoin, this idea of the public key was generalized, and it was replaced by a small scripting language that allows you to encode custom conditions that go slightly beyond checking the signatures. So in the simplest case, you would have a little program that simply checks a signature, just like with a plain public key. But you could customize this program by saying, I want not 1 signature, but 2, or I want 2 signatures out of 3 public keys, or I want a little bit of a time lock check, or maybe some conditions, like one branch of a contract or another. And this way you can make small smart contracts as predicates on those accounts. But you don't have a lot of room for arbitrary storage, and you have to recreate the state of the account if you make any changes to it. Because every time you transfer funds from the account, it's destroyed, it's marked as spent, and then you have to create new ones. And this is a short overview of how Bitcoin works. This is pretty simple. And our next step in the blockchain evolution is Ethereum, that tries to generalize the idea of Bitcoin and make it more flexible for developers. So Ethereum starts with an idea that every account may not only have the predicate code, but may also have arbitrary internal storage. So you may imagine that your transactions no longer just transfer the cash from one account to another, they can now transition from one state to another. And this is a big idea of Ethereum. And the second idea of Ethereum is that the accounts may communicate with each other, and they can send messages synchronously to another account, just like calling functions in a single application. And this is why Ethereum is often called global computer, because the whole state of the blockchain with all the accounts acts as a single program where multiple various functions and modules are loaded at the same time. And anyone who is accessing this computer, they're sending their transaction, they could access and trigger any function in the entire blockchain. And this is very cool because it gives the developers the familiar experience of programming their own computers, and it's compatible with many known tools and programming paradigms. However, this comes at a huge cost of scalability, because now for every transaction, anyone who is verifying this transaction, every node in the network has to store the entire state of Ethereum blockchain on their computer, and they cannot process other transactions before they finished with the current one. So Ethereum model is very flexible and very friendly to the developers, but completely unscalable in principle, because it kind of exposes the developer and all the contracts to this global storage and global state of the system. And now we come to Ton. So the Ton's idea is to figure out how to provide the developers with this infinite flexibility so they can express all sorts of applications. Like Ethereum demonstrated, this DeFi revolution started happening on Ethereum, and this is clearly a validated need on the market. But how do we make it scale? And here we could take some lessons from both Ethereum and Bitcoin. So in Ton, you have, just like in Ethereum, you have individual accounts that have their own state, but you add the limitation. You say that the contracts are not allowed to see the global state. They can only see their own state. And the only way that they can communicate with other contracts would be asynchronous message passing. So the complicated rules of the network will take care of routing the message, and sometimes it may take multiple hops. But in principle, at no point in time, no party in the network would have to see the entirety of the global state. In Bitcoin, if you recall, every transaction destroys the input account and creates the output accounts, or they're called inputs and outputs simply. And this means that if you have two transactions that access different accounts, they are completely independent from each other. And in Ton, this is a similar idea. Every time you make a transaction in a contract, this transaction is 100% independent from another transaction on a separate contract. And those could be processed in any order or independently. And what transaction does is it takes the input state of the contract and produces the new next state of the contract, which is recorded on the blockchain. And this is quite similar to Bitcoin, except in Ton, all those contracts could be sharded, and also they could communicate with each other, and those messages are routed by the system. While in Bitcoin, all the state of all the contracts is stored in one single global state of unspent outputs. So to sum it up, Bitcoin approach is not quite scalable, but it's also very not flexible, so its scalability properties don't really hurt people, and it can work for millions of people. While Ethereum is definitely way more flexible and very friendly to developers, but this comes at a cost of non-scalable architecture. Ton takes a different approach. Ton optimizes for infinite flexibility and infinite scalability, but this comes at a cost of developer experience, because the model of Ton is very unfamiliar to developers, and this is also the reason why we're making this course, to help developers to understand Ton architecture better and make the full use of it. And in the next lessons, we'll dive into more details on how Ton works to help you understand it better and take full advantage